In today's video, I will talk about inequalities. In grade 10, we have already learned linear inequality. So when dealing with inequality, we use the same basic principles as for equations. That is, anything we do to one side of an inequality, we also do the other side. So for example, if we plus or minus on one side, we have to do it on the other side, the same thing. However, for inequality, if we multiply or divide both sides by a negative number, then we need to reverse the inequality sign. That is, greater than becomes smaller than, greater than or equal to becomes smaller than or equal to, and so on. So for example, for example 1, so for this one, we first minus x on both sides. We have 2x smaller than -1. So divide by 2 on both sides, we have x smaller than or equal to -1/2. That's normal. But for this one, if we minus x on both sides, we have -3x greater than 7, and we divide -3 on both sides, the signal should change, right? So it becomes x smaller than -7/3. That's in grade 10. In grade 11, we have to learn quadratic inequality. So quadratic inequality, we first move everything to one side, and then either by factor or by quadratic formula, we can find the two solutions. For example, in this one, by factor, we find two solutions, that is 1/3 and -2. So then we have two methods. So method 1, we can use the sign diagram. That means we draw a number line and put our two solutions on the number line. Then we consider the sign in different areas. So for example, when x is smaller than -2, for example, we pick a number -3. So -3, we plug in, right? So -3, this becomes negative, and this is negative. And negative times negative is positive. So this area is positive. And between -2 and 1/3, for example, we pick point 0. So this becomes positive, and this is negative. And negative times positive is negative. So this area, the value will become negative. And the last area, we can pick 1, for example. So this becomes positive. This is positive as well. Positive times positive is positive. So this area is positive. So in order to, we want to know which area makes the value positive, greater than equal to 0. So we pick this area and this area. So the solution is x smaller than or equal to -2, or greater than or equal to 1/3. And the second method I highly recommend is graph the function. So first, the same thing, we find two solutions, 1/3 and -2. The second step is graph the corresponding function in this problem. So fx equal to 3x squared plus 5x minus 2. And then we can draw a graph, right? We already have two solutions, -2 and 1/3. And because it's open upward, so we can draw a draft like this. And now the question becomes, if fx is greater than 0, this is fx is greater than 0, what is the value of x? That is, what's the value of x makes our fx greater than 0? So as you can see, any point here or here, fx is greater than 0. That means the x value from here to here and here to here will make the y value greater than 0. So we have x smaller than or equal to -2 or greater than or equal to 1/3. So in my opinion, this method is more straightforward. You just need to find the two solutions and draw a draft. You don't have to do the sign diagram, right? And if the question becomes fx smaller than 0 in some cases, you just need to pick this area. So pick the area in between is where fx smaller than 0. And finally, we can discuss some, give example of one rational inequality. So in this one, we have to be able to do some discussion, because our first step, our natural first step will be we want to time x minus 4 to the other side, right? But in this case, if x minus 4 is positive, when you times, the inequality sign will not change. But if it's smaller than 0, if you time, the sign will change the sign, right? So we have to do some discussion in this case. So the first scenario, if x minus 4 greater than 0, it cannot be equal to 0, right? Because it's the denominator. So if x minus 4 greater than 0 or x greater than 4, we can time x minus 4 to the other side without changing the sign. So 3x minus plus 2 smaller than or equal to x minus 4. Then we have 2x smaller than or equal to -6, and x smaller than or equal to -3. But remember, this is under the condition of x greater than 4. So in this condition, x greater than 4, then x smaller than or equal to -3 is impossible. So there's no solution in this case, right? And second scenario, if x minus 4 smaller than 0 or x smaller than 4, if we time x minus 4 to the other side, the sign will change, right? Then after solving, we have x greater than -3. Remember, this is under this scenario. So this scenario, we have x smaller than 4, and we find out x should also greater than or equal to -3. So it's the area they intercept. So it's x greater than or equal to -3 or an x smaller than 4. And then we combine these two scenarios together. We have it's x. We find the value of x. So the number line in this case will be helpful, and then you combine the solution together, you will find the final solution. So all in all, you should be able to do this kind of discussion for rational inequality. Okay, thanks for watching.